We're looking at homework from section 2.5. This is question number 19. The lifespans of a species of fruit fly have a bell-shaped distribution with a mean of 33 days and a standard deviation of 4 days. A. The lifespans of 3 randomly selected fruit flies are 36 days, 29 days, and 43 days. Find the z-score that corresponds to each lifespan. Determine whether any of these lifespans are unusual. And B. The lifespans of 3 randomly selected fruit flies are 45 days, 37 days, and 41 days. Using the empirical rule, find the percentile that corresponds to each lifespan. So we'll start with part A. We're going to look at each one of these different fruit flies separately. So we'll start with 36 days. That means our x is 36. We use our z-score formula, which is z equals x minus mu over sigma, where the x is 36, the mu is 33, and the sigma is 4. 36 minus 33 is 3, so this is 3 divided by 4, which is 0.75. So that's our z-score for the lifespan of 36 days. For the z-score that corresponds to a lifespan of 29 days, x would be 29. We're using the same z-score formula, but now the x is 29, the mean is 33, and the standard deviation is 4. 29 minus 33 is negative 4 over 4, and negative 4 divided by 4 is negative 1.00. That's the z-score for the lifespan of 29 days. What about 43 days? When x is 43, our z-score is 43 minus 33 over 4, which is 10 over 4, which is 2.50. So that would be our z-score corresponding to a lifespan of 43 days. Select all lifespans that are unusual. Remember that when you have a z-score, values for the z-score that fall between negative 2 and 2 are considered usual and typical, but any data value that has a z-score less than negative 2 or a z-score greater than 2 would be considered unusual. So the z-score of 2.50 is unusual, and that lifespan was 43 days. So 43 days would be considered an unusual lifespan. What about the last question, about the empirical rule? Determine the percentiles of these 3 randomly selected values using the empirical rule. So the empirical rule relates our bell curve to certain percentages that fall underneath that curve. Within 1 standard deviation, you would find 68% of the data values. Within 2 standard deviations, 95%. And within 3 standard deviations, 99.7%. So we put our mean here, which was 33, right in the middle. And then because the standard deviation was 4, we move out in 4-day segments. So we go 1 space to the right, 1 space to the left, and that's going to get us to 29 to 37. If we go another space left and right, that's going to be 25 to 41, and another space left and right will be 21 to 45. So we were asked about a 45-day fruit fly. Well, the 45-day fruit fly would be from this point on your normal curve to the left. So how do we figure that out? We need to have a few more percent values here. And what we need to know is that if we go from the center in either direction all the way out, that we have 50% of the data values from that point outward. When we're at the 45 days, so we add 2.35, 13.5, and 34 to this 50, and that gets us the 99.85 percentile. So when we're looking at the 37-day fruit fly right here, the 37-day fruit fly corresponds to a percentile value of 34 plus 50 from the center to the left, which would be the 84th percentile. And then for the 41-day fruit fly, we count up the percentages to the left, because remember, percentiles represent what percent of data values fall below on the particular graph. So that's going to be 13.5, 34, and then this 50 from the center to the left. And when you add those together, you get 97.5. So we have the 99.85th percentile, the 84th percentile, and the 97.5th percentile. That's your answer.